In this next unit, we begin to discuss matter. As you may remember, matter is anything that has mass and takes up space, or volume. In this unit, we're going to look at different ways to classify matter. One obvious way to classify matter is by its physical state of matter, which is solid, liquid, and gas. If I was to draw a line from left to right, that represents the amount of energy the particles have. So as we go from left to right, the amount of energy increases. You would see that solids are going to be way over here on the left, meaning they have significantly less energy than liquids, which we'll put about right here, and gas, which I'm going to put way over here. Now, if we look closely, we're going to see that solids are made of tiny particles, as everything is. Now we'll notice that these particles still have energy. They are not at absolute zero. So they're actually kind of moving in two ways. They can rotate and they can vibrate, so they still have energy. Notice the particles are stuck together. So therefore, if you think about a solid, you'll probably say that it has a definite shape and a definite volume. This means that you can't compress them a whole lot. There's not a lot of space in between the atoms, so therefore you can't really compress them very much. Now we'll go into more detail later about crystalline structure and amorphous structure. Other things we can say about solids at this point are they're very dense, meaning the amount of mass per volume is great because it doesn't take up much space. Now, let's move on to liquids. So if I am moving to liquids here, the liquids, if I have the same amount of liquids, you'll notice I did 9 particles in each one of these. So that's constant. We're just getting a little bit warmer. So what we just did actually was we went from solid to liquid. So this is melting. So now that we're in liquid, the liquid state, we notice that there's a little bit more transitional movement. So these guys can actually slide past one another, all 9 of them. So since they can slide past one another, we need to put them in a container so that it doesn't just go all over the table or whatever it's on. So this needs to be in some sort of beaker or container. Now, notice there's not a whole lot of space between them. So because there's not a whole lot of space between them, it still is not very compressible. So we're going to say that liquids have a definite volume, but not a definite shape. When we discuss liquids later on, we're going to discuss things such as viscosity. We're going to say that liquids are a fluid. We're going to say that they're not very compressible. Now, typically, they are less dense than a solid because there's a little bit more space. The only exception to that is water. Liquids undergo capillary action. They're going to have adhesion and cohesion. You can dissolve things in water and other liquids. Now notice, if I was to remove energy from a liquid, this is freezing. So liquid to solid is freezing. So that's freezing. Now, if I continue to increase the temperature from a liquid to a gas, we're going to undergo a process called vaporization. And while we're at it, let's go the other way. Gas to liquid, so removing energy, I'm going to represent as blue, is known as condensation. Now we're talking about gases. Now gases are much more spread out. So gases, if I'm drawing our 9 particles, I'm going to represent with longer lines. This means they have more energy. The particles are moving faster. There's very little attraction between the particles, if any. And notice, since there's no attraction to one another, you need some sort of container to hold these in. So, we're going to do our very scientific balloon. And we'll notice that they do not have a set volume and they don't have a set shape. No set volume or shape. So gases undergo all of the movements discussed previously. They're known as a fluid state because they are moving past one another. Pressure is caused by the collisions with themselves and other objects. The intermolecular forces I previously mentioned, or the forces holding them together, is much less than the kinetic energy, or the energy of them moving past one another. Gases are going to be highly compressible. This is because all the volume or space between the particles. And they're going to be extremely low density due to the very large volume. In this next problem, I'm going to classify changes as either physical or chemical. The main thing you need to ask yourself is, do I have the same substance after as I did before the change occurred? If I have something new, then it must have been a chemical change. If it's the same thing, but maybe just a smaller piece, then it's a physical change. So silver tarnishes. This is silver undergoing an oxidation reaction. This is a chemical change. I no longer have just pure silver. Afterwards, I have a combination of silver and oxygen. Calcium nitrate dissolves in water. Anything that's dissolving in water is still the same thing after. It's just dissolved into its ions. So this is a physical change. Sodium metal is sliced in two. Anytime something is cut or broken in two, that is a physical change. I still have the same thing after, just smaller pieces. Liquid water is turned into steam. This is a phase change. All phase changes are physical changes. Now, I had liquid H2O, I boiled it, and I have gaseous H2O. It's still H2O before and after. Wood rotting, now before the change occurs, I have some sort of log or tree or something. After the change occurs, I no longer have any of this same material. Now it's rotted. Therefore, this is a chemical change. Food is digested. That is a chemical change. Before I have food. After I no longer have food, I have something else. That's a chemical reaction. A metal is heated until it melts. This is once again a phase change. Therefore, it is a physical change, going from solid metal to liquid. Water is distilled. This is also a phase change. I'm boiling the water from liquid to gas. I still have water before and after, therefore physical. A plant grows. This is a chemical change. This is always difficult for students to grasp, but photosynthesis is occurring and the glucose is being deposited on the end as cellulose. Therefore, it is a chemical change, photosynthesis. On this next diagram, I will separate matter into basically two categories, one of which is pure substances and one is a mixture. Now, mixtures would be two or more pure substances combined, not chemically, just sort of blended or mixed together. Now, these things can be separated by physical means so that I could separate a mixture into its components by using a physical method. A physical method would include something like a filter or maybe distillation or something that's separating based on the mixture's physical properties. So now, mixtures I can further break down into homogeneous or heterogeneous. Now, homogeneous is the same throughout, so therefore homogeneous, you cannot see two different phases or parts to it. A phase is a different part when you're talking about a mixture. Another word for homogeneous would be a solution. Alloys are solutions as well, so alloy, solution, homogeneous mixture. So that is clearly mixed completely together. Heterogeneous, you can see two different phases. So that's this over here. Hetero means different, so you can see two different phases in this. Now, that's mixtures. On the other side, we have pure substances. Pure substances cannot be broken down by physical means. These are things that are either elements or compounds. Elements cannot be broken down any further. There's about 92 naturally occurring elements. And compounds are composed of two or more elements chemically bonded together. So you cannot separate a compound such as H2O into its elements physically, meaning I can't put water in a filter and get hydrogen gas and oxygen gas. The only way to separate hydrogen from oxygen in water would be a chemical process, such as electrolysis. That leads me to my final type of problem. Classify the following types of matter as pure substance, which is an element or compound, or a mixture, homogeneous or heterogeneous. Now, what we need to do is evaluate each one and see where it fits on that flowchart. Beryllium is an element, so it is a pure substance or element. Gasoline is mainly made of octane, although actually there's other things mixed in together. So octane would be a compound, which is a pure substance. However, there's other additives in there, such as detergents and such. So this is a mixture. Now, because you cannot tell a difference between one spot to the next, it is a homogeneous mixture. So, mixture. Okay? Next, water. Water is a pure substance. It's a compound that's chemically bonded hydrogen to oxygen. So, therefore, this is a compound. Okay? Now, air next. Air is a mixture of nitrogen, oxygen, carbon dioxide, various other trace elements, water vapor. And so air is a mixture, and you cannot tell the difference between one and the other, so therefore it is a homogeneous mixture. Carbon dioxide is a pure substance, chemically bonded together, so it is a compound, CO2. So that's two elements chemically bonded together. Sand. Now sand is a mixture, but if you look closely, I think you could see the different types of sand grains, and therefore you would find that it is a heterogeneous mixture because you can see a difference in sand. So that is a mixture. Now, brass is a mixture, a homogeneous mixture made of two elements. It is made of zinc and copper. Now, what you would do to make something like this is you would take it in the right proportion, you would melt the metals, mix them together, and then let it solidify. And so therefore, it is a mixture of two elements that are not chemically bonded together. So it's a homogeneous mixture. When you look at brass, you can't tell that it's made of different things. So it is also known as a solution. So therefore, this is a homogeneous mixture. And that's it.